So in section 2.2, we're going to be looking at histograms, and we'll revisit some frequency distributions. So here in this example, we have a collection of raw data. So the number of hours that classmates spent playing video games during the weekend. But before we construct our histogram, we're going to want to figure out our class width. Okay, so we're going to first do it a traditional way, and then we'll go ahead and look at a more simplified version. So if we look at our data, we're going to look at the smallest significance level here. So here we have one single digit decimal place. We typically want to go one more beyond that for accuracy. We're going to simplify it, and we're just going to go ahead and go to 0.5, and we're just going to go with the same accuracy as listed there. The reason you always want to go one more decimal value is so that one of your data values doesn't fall exactly on the boundary, and we could decide in what class it'll actually fall in. Okay, but let's just use 0.5 for simplicity. And so we're going to take the smallest value here, which is 0, and we're going to go ahead and subtract that. And that's going to give you your starting point. So that's going to give us negative 0.5. Similarly, we'll take the largest value, which is 24, and we're going to go ahead and add that accuracy of 0.5, and we'll get 24.5. And that's going to be our ending value. Usually the number of classes should be given to us. So let's say we want 5 classes here. The class width is going to be the ending value minus that starting value. So we're going to subtract those two and divide it by the class width. And so in this case, we get a value of 5. Now, if it's a decimal, we always want to round up to the nearest integer. And we're going to get that class width, and we're going to start at our starting value and keep adding intervals of 5. So here's our classes from negative 0.5 to 4.5, and we're going to keep adding 5 to those. And we're going to call these the boundaries. Okay. Now note that these here are the same value, and this is why we typically want to go to a bit more of accuracy, so none of our values fall on the actual boundaries. But we're going to be in the clear for that, and we'll just go ahead and do it with one decimal of accuracy. Let's look at a simplified version. If we know we want 5 classes, we could go ahead and look at the largest and smallest value here, which is going to be 0 and 24. And if we want 5 classes, that's roughly about 25, so I'm just going to make widths of 5. And so I'm going to go from 0 to 4, 5 to 9, all the way through to 24. Now, note that it seems like this class is a width of 4, but let's consider 10 through 14. We're actually counting 10, 11, 12, 13, and 14. So there's 5 values there. So it makes it just a little bit more aesthetically pleasing rather than having to use the boundaries with all of those decimal values. Most computer programs do it in this fashion, and the whole goal of making a graph is to make it visually pleasing as well. So we're going to go from 0 to 4, 5 to 9, 10 to 14, etc. there. And these are called the limits. Okay, now that we have that, okay, so let's go ahead and first construct a frequency distribution. That's going to help us to make a histogram and really any graph that we want. And so we're going to start with the class limits. And then let's go ahead and put the boundaries since we calculated those as well. So the class boundaries. And now again, if we don't have the class boundaries, typically what you could do is get the midpoint of those two, and that's going to give us these values here. So let's go ahead and get a tally going now. And so the tally is going to keep track of all of the data values. So if we see that our first value here is 9.2, we know that falls in the second class there. So I'm going to put a little tally mark just to keep track of that. The next one is 10, so that's in the third class. And then we have 2.3, which is in that first class. And we're going to go through all the data and just mark all of these up here. So one by one. And ultimately, I'm not concerned about the tally. I just want the frequency count. So that's just a nice way for me to keep track of the values. So the frequency here, we see the first class has 2 values that were between 0 and 4. And we're going to go ahead and do that for each one of those classes here. And always a good idea to add them up to make sure you get your total, that you have all the values there. All right, let's also construct then a relative frequency. And if you recall, this is just the proportions here. So how many in each class out of the grand total? Let's next do a cumulative frequency here. So for the first group, I'm going to have 2. So how many are in that first class there? Then for the next one, we're going to have 2 plus 3. So how many were in the class before and how many are in this class? So we're accumulating everything. Then the next one's going to be 5 was in the previous one. And then plus 4, so how many in this class and everything before it? And we're going to do that all the way through. So this is a cumulative frequency. And at the end, we should get 25. Let's also do a cumulative relative frequency. So same idea, but now we're doing it with the relative frequencies. And so we're accumulating for each one. And our total should be approximately 1. Again, we say approximately because there could be some errors with rounding. Okay, so here's our frequency distribution. We should also add the midpoints here. And if you recall, the midpoint is really the mid-range of a class here, which is the upper limit plus the lower limit, and we're going to divide it by 2. So it's really just the average of those. So for example, here if we go 0 plus 4, the right smack in the middle is going to be 2 in this case. When it's not as easy to tell is, let's look at the next one. If I can't tell exactly where the center is, you could always go ahead and add those 2 and divide by 2. That'll give you that midpoint there, 7. And so we're going to go ahead and do that for all of them. And one thing to note is once you get a pattern going here, once you do a couple of them, whatever the class width, that's how much it is to jump to the next one. So these are going by 5s because that was our class width there. Now this is probably all the values you will need to calculate for a frequency distribution. You don't need all of them all of the time, but it is nice to just have everything there, and then we could construct any type of graph that we want. So we'll just go ahead and copy the frequency distribution over here. There we go. Okay, so there's our entire frequency distribution. And so let's go ahead and try to get into these graphs here. So now we can look at the histogram. And again, I'm labeling that x-axis class limits with hours. Here we have frequency. Those are classmates there. Okay. And so what we're going to do then is I want frequency versus class limits. So those are the 2 that we're looking at. So in frequency, we have a height of 2 here. And so our first class is going to go to that height of 2, which is marked right about here. And notice our class limits goes from 0 to 4. So that's going to be this little interval right here. And so one thing to note is that this class here looks like it goes from 5 to 10. Now, it really only goes from 5 to 9. But for computer programs and when we put the limits, we assume that the value on the right is the start of the next class. So even though it shows 5 to 10, we know that's going to go from 5 all the way up to 10. 10 is really the start of the next one there. And let's do the next bar. This one's going to go up to a height of 3, and so on. So 4, 7, and then 9. And always a good idea to label them. And so here's a histogram. Again, nice and clean. I chose the limits because they're nice numbers. It's very easy to see there. Although the boundaries could be more accurate, this is just a nice clean image of the data here. And we could see which class has the highest and how everything relates here. Okay. Let's start a frequency polygon here. So this time we're going to use midpoints and the cumulative relative frequency. Okay. And if and so the cumulative relative frequency, we know at max is going to be 1, so we're going to label that there. And the midpoints on the x-axis, we could label the midpoints, but again, the idea is to have a nice clean graph. So we don't necessarily need to label the points we're plotting. A lot of times we just want to label some nice values on that x-axis. But we know the midpoints are going to be in the middle of these. So here we're going with, so there we go. So we're going to go ahead and plot these. And if we have a frequency polygon that ends up increasing, then we typically call that an ogive curve there. And this, let me do a minor adjustment here. Technically, just to be correct, this is going to be right in the midpoint. So we should have made our dot right about there.